In this video, I'm going to demonstrate how to graph functions using Desmos. So when you open up Desmos, this is what you are going to see. On the right-hand side, you have your graph, and you can move the graph around here, left-clicking on your mouse with a little arrow and holding it down, and you can move it. Or you could go over here to this little house and just click that, and it will bring you back to what is a standard view. On the left-hand side is where we're going to enter our equations or functions. And we can use equation notation or functional notation, and I'll demonstrate a little of both. So first of all, let's enter a function. F of x is equal to some linear function like 3x minus 9. So I'm going to type in f, a left paren, x, a right paren, equal, and what I say, 3x. Now, we know that 3x is being multiplied without putting any operation symbol in between the 3 and the x. And fortunately, Desmos knows this at all. In some programs, you have to actually tell it to multiply by putting some symbol like an asterisk between the 3 and the x. Desmos, you do not need to do that. For multiplication, just type in 3x. For addition or subtraction, let's do minus and 7. And it automatically graphs the line. Now, once again, I can left click on my mouse, hold it down, and I can move this line around so I can see it. I can use the mouse to scroll out for a wider view or scroll in for a bigger view. And if I get kind of a weird view here and I want the standard view back, I can just go over to the little house over here and left click on it. Boom, and I have my standard view back. So this is in functional notation, and this is a linear equation. Now we can also enter an equation such as 4x minus 8 equals 2x plus 1. And there we have a linear equation. Let's make it 12. 2x plus 12. Now, where is my line? Oh, there's my line. I'm scrolling out with the mouse to see my line. And of course, it is a vertical line because I don't have any y's in here. If I wanted to put a y in here, let's say I put plus 5y. Now I have two variables. And notice that as complicated as this equation is, Desmos has no problems graphing it. On some programs, including graphing calculators, you usually have to solve it for y first. You do not need to do that with Desmos. And I could change this equation. I could put over here 4x minus 8. Let's say I just want to add in a minus y over here. I can do that. And Desmos will just recalculate it. And then I can go to the little house, left click, and it gives me my standard view back. So I have an equation, a linear equation. Both of these are linear, a linear function and a linear equation. If I click on this little blue squiggly line over here, notice that the first graph of the function went away. So I can make it come back by clicking on that. It'll go away, come back. I can make the second line, the equation, go away. And now I have nothing, and I put the first one back. So if I want to see just the first line, or if I want to see the second line, or if I want to see both, I can do whatever I want to do just by clicking on one of these. Now, one of the nice things about Desmos is, let's just look at the second line, is it tells us where it crosses the x and the y axis. So clicking on the line and then moving down here, I can see that the y-intercept is 0 and negative 3.33. The x-intercept over here is 10, 0. So Desmos is very nice that way. It tells you the intercepts. I can see the intercepts of my first function, click on the line, and now I can go up to the x-intercept, 2.3330. The y-intercept is 0, negative 7. If I look at both of them, and this is something that we'll be doing later on in our class, is I can see, clicking on either one of the graphs, I can see where they intersect. So just scrolling down to this little dot right here at the point of intersection, and this is the point where the two graphs intersect. Well, I can graph other things. I could graph a quadratic, y equals x, and then we're going to use the little caret, the upside down v above the 6, to get an exponent, x squared. And notice it's already started graphing it, even though I'm not finished with it. Now, to continue this function, we need to get out of the exponent. So hit the right arrow key. Now, notice that when I hit the right arrow key, the little line over here dropped down. If I do the left arrow key, it goes back into the exponent. And if I type something like x, it's going to put it in the exponent. So I don't want to do that. So I'm going to left arrow key back, delete that. Right arrow key to get out of the exponent, I'm going to put in a plus 5x minus 2. And there is a quadratic, an upward turning parabola. Let's get rid of the first function there and just take a look at these two functions. So I can see where the parabola crosses the x-axis. It has two x-intercepts, one here and one here, and here is its y-intercept. I can also see where the parabola and the line intersect. Again, this is something that we will be doing when we find the area between curves, is we will need to determine where the two graphs intersect. So here's one point of intersection, and here's the other point of intersection. And I can click on the little house to get my standard view back. All right, another interesting thing that Desmos can do is you can limit the domain. In other words, the x values. Let's just take a look at the parabola. What if I only want to see the parabola over part of its domain? In other words, only certain x values. So I'm going to hit the space bar here a couple of times, and then I'm going to shift and hit the little squiggly mark there for the squiggly brackets. That's what I call them, the squiggly brackets. And I'm going to put in a -2. Then I'm going to hit the less than key, the equal key. Notice then it made it less than or equal to. Then x, and then I'm going to do a less than and my right bracket to finish it off. Oops, I'm sorry, I didn't put a number in there, but let's put 6. There we go. That's better. So what this is saying is we are restricting the domain from -2, including the -2, because x is less than or equal to -2, up until 6, but not including the 6, because x is less than 6, not equal to 6. And you can see this on the domain. First of all, let's scroll out so we can see the entire graph. Notice that the graph is only going from -2 to 6. Let's say I want to make that -12. I could just put in a 1 in front of there. And now it's going from -12 to 6. We can see a little bit more of the graph. I could change this perhaps to 16. Now I can see a different part. So we can kind of change what we want to see on the graph just by changing these numbers in here. Now I have a 5. All right, one last thing about this is let's zoom in a little bit closer. Let's click on the line, left click, and let's just hold down the left mouse and let's go all the way to the end. And notice the end, the ordered pair at the very end is -1282. Well, the x value is -12. That's our smallest x value. And the function value there, or the y value, is 82. And notice that there's a little closed dot right at that point, because x is equal to that point. X is greater than or equal to -12. But as we go the other way around to this point, right up to the end, notice we get something different. Notice that there is a little open circle at the end. That open circle represents the fact that we do not include the 5 at the end point. And so when x is 5, the function is undefined. There is no value at 5. It's just serving as a boundary point or an end point. And that's why the open circle says we're going up to that point, but do not include that point, because over here it says x is less than 5, but not equal to 5. One last thing is let's put in some sliders. So I'm going to write in y equals ax plus 2. And it says add slider. So I'm going to click on that. And so what it does is it puts this little scale down here, which is a slider, and we can move this back and forth to whatever we want. Notice how the a value changes. So the ax, a is acting as the coefficient of the x, which we know from linear equations is also the slope. And I can just type in some value of a. Let's say I want 2. And so now the function is graphing it as though x was 2. So we have y equals 2x plus 2, which is a slope of 2 and a y-intercept of 2. What if I wanted to see what it would look like with a slope of 5? Then I could just type a 5 in there. Or I can get my slider back and I can just move the slider to whatever I want the slope to be. And notice as we change the value of a, the slope or the steepness of the line is changing. Now, right now, the smallest value is -10 on this scale, and the largest value is 10. We could change that if we wanted to. So I could say I want this to go to 30 and -20. And so now it's changed the slider from -20 to 30. And another neat thing that we can do is I can just go over to this little arrow over here and click on it. And now it's just going to move the slider back and forth all by itself. And of course, we can do other things like adjust the speed if we want, which is kind of nifty. All right, and then I'm going to stop that. I can also add a slider in here in place of this 2. I could put in a B. Now it's going to say add a slider for B. Okay, B represents the y-intercept. So now the y-intercept is going to change. So notice that the graph is changing its y-intercept. And it's going from -10 to +10. Let's zoom in a little bit on that. Notice, see that the going down from -10 and the y-intercept is going up to +10, and then it's going back down to -10. I could change both of these if I wanted a really funky graph. So now A and B are constantly changing. Not something we're going to do a lot, but it's kind of fun just to look at. All right, that pretty much sums up most of the important things that we're going to be doing with Desmos in this class. You need to be able to know how to graph a function. Sometimes we're going to want to limit the domain. Sometimes we're going to want to put in sliders. So play around with this a little bit. Make sure that you be comfortable with using Desmos.